Yeah, so hello all, welcome to lecture number 18. So today we'll continue our discussion on AC circuits with a pure inductor. So let's solve one numerical on it. So write down numerical. A voltage, yeah students please note it down. A voltage of 150 volt, 50 hertz is applied to a inductance of 0.2 Henry. Write the time equation of voltage and current. So let's write down the given data. For us given is value of L is given as 0.2 Henry. V is 150. What it is, peak value or RMS value? RMS value. And F is 50 Hertz. Okay. So this is RMS value. And this is the situation. We have been given a AC supply is applied across the inductor of value 0.2 Henry. And we need to find the expression for I and V. So let's start. Everyone has reached up till here? Okay, so let's write down the first step. So XL is given by 2 pi FL. So first calculate XL. XL will be 2 pi into 50 into 0.2. That will be 62.83 ohms. Please check. Second, what is the expression for V, VM and IM? I mean V is VM sin omega t, and what is the expression for I? I am sin omega t minus pi by 2. Please also calculate VL. VL will be I into XL. So what will be I? VL upon XL. Now tell me, so no, everyone please listen. This voltage is VL. Is this voltage same as this voltage? Parallel, no? This VL is same as this V, right? And RMS value of that. So VL is how much? 150. Did you get it? We didn't know the value of I, that's why we are calculating VL, and VL is same as V, RMS. And what is XL? 62.83. So we get the current over here, RMS value. So how much it is? 2.387. Just check. And this is again the RMS value. Why we require I? Because we need to calculate IM. Now, next thing is calculate IM. What will be IM in terms of IRMS? Root 2 times IRMS. So that will be root 2 times 2.387, which is 3.376 amperes. Please check this value. Similarly, VM will be root 2 times VRMS. That will be root 2 times 150. How much is this? 212.13 volt. Please check. Same? Okay. Then we calculate omega. Omega is 2 pi f. That is actually 2 pi into 50. That is 100 pi. That is nothing but 314 radians per second. Now we can write the expression of V and I. So V will be Vm sin omega t. Vm is 212.13 sine of 314 t. Similarly, I expression will be Im sine omega t minus pi by 2. So it will be 3.376 sine of 314 t minus pi by 2. These are my expressions of V and I. Okay. So this ends our discussion on AC circuit with a pure inductor. Now next we'll start with AC circuit with a pure capacitor. Okay. Completed up till here? So next write down AC circuits with a pure capacitor, or it is also called as capacitive circuit. Can we start now? Alright, so let's start. So consider a voltage Vm sin omega t. V is equal to Vm sin omega t applied across a capacitor. Now capacitor symbol is like this, two parallel plates. Okay, this is C. So because of this AC voltage, AC current will flow small I, which is given by Im sin omega t, and this will create a voltage drop Vc. Vc stands for voltage across the inductor. Remember, this I is my AC current and this V is my AC voltage. Okay, so AC voltage V is equal to Vm sin omega t is applied to a capacitor. So as a result of this AC voltage, current I will flow through the circuit. So I will be given by Im sin omega t, right? Now, what is the charge on the capacitor? Charge on the capacitor will be given by, do you notice notation for charge? Q. Now charge on the capacitor is given by C into V. And what is the circuit current given by? Circuit current is given by rate of change of charge. So circuit current I will be dq by dt. So d by dt of C into V. Actually it is V. Okay. So I will be, C is constant. So d by dt of Vm sin omega t. So what is differentiation of sine? Cos, and omega will come over here. So it will be Vm omega cos omega t. Got it? So what will be I? I want to write in the standard form. Omega c Vm sine of omega t plus y plus cos theta is sine theta plus y by 2. Got it? Remember, in an inductor it was minus and here it is plus. That means current will lead the voltage by 90 degree. Okay. We have written up till here. Please put it inside the box and call it equation number 1. Now when will be value of I maximum? Value of I will be maximum when sine of omega t plus pi by 2 will be equal to 1. So write down value of AC current I will be maximum that is Im, when sine omega t plus pi by 2 will be equal to 1. So what will be I now? I am omega c Vm, called as equation number 2. Okay. So what will be I given by now? I will be given by Im sine of omega t plus pi by 2. Now if I compare this equation 3 with V is equal to Vm sine omega t, what can I say? Current is leading the voltage or voltage is leading the current? Current is plus 90. So current is leading the voltage. From these two equations, we can say that current I, AC current I leads AC voltage V by pi by 2 or 90 degree. Got it? This is the learning from it, from this whatever analysis we have done. In a capacitive circuit, current leads the voltage by 90 degree. So we can write over here in a pure capacitive circuit, AC current leads AC voltage by 90 degree. Therefore, the nature of the circuit is capacitive. So whenever in a AC circuit the current leads the voltage, that means it's a capacitive circuit. And now you need to draw the timing diagrams, that is V versus time and I versus time. So how will you draw it? First, let me draw the sinusoidal waveforms. So these are my AC waveforms, AC voltage waveform. Okay, this is V. How will I draw I? It's before, right? This is pi, this is 2 pi, 3 pi, and this will be before. Okay, this is my AC current. It starts a little before, okay? So this is I. And what is my phase difference? This is my phase difference. Phi is 90 degree. Got it? So here we can say clearly that current leads the voltage by 90 degree. Draw the phasor diagram next. X-axis is what? Theta equal to omega t. Please draw the phasor now next. So how will be my phasor diagram? So if this is theta equal to omega t, and if this is V, where will be I? Up or down? Above, here. Got it? So this will be I and this is V. This is V. And what is the phase angle between them? 90 degree. So you can clearly see over here that the current leads the voltage by 90 degree. This is 90 degree or pi by 2. And this is my phasor. Please draw this. So from here we can say that your current leads the voltage by 90 degree. Okay. So therefore, the phase angle of the circuit is phi equal to 90 degree or pi by 2. Alright. And now we write opposition to the current Z. What will be Z? You completed up till here? Okay, I'll give you all 10 seconds more. Alright, now we'll correlate and find what will be the impedance of the circuit, Z. So write down opposition to current in a capacitive circuit. Opposition to the current Z. So what it will be? First of all, what is Im given by omega C Vm? So what will be Vm upon Im? 1 upon omega C, right? So we can write it as Vm by root 2 upon Im by root 2. What it is? 1 upon omega C. What is Vm by root 2? Vrms. And what is Im by root 2? Irms. So V upon I will be 1 upon omega C. And in a AC circuit, what is V upon I given as? Z. Okay. So what will be impedance over here? In this case, in a capacitive circuit, Z will be 1 upon omega C ohms. Okay. Sorry. There is a same point again. 10 point. Okay. Okay. 10th point again. Okay. Okay. Fine. Im is omega C Vm. So Vm upon Im is 1 upon omega C. We divide numerator and denominator by root 2. So V upon I will be 1 upon omega C. That means impedance will be 1 upon omega C. And what is opposition by a capacitor to the current given by capacitive reactance? Okay. So ready? Now write down point number 11. Opposition offered by capacitance to AC current or AC quantities is given by XC, that is 1 upon omega C ohms. So over here the quantity XC is called as capacitive reactance. So XC will be 1 upon omega C, or it is also called as 1 upon 2 pi FC. This formula will be used many times. XL and XC will be used many times in your numericals. Next, what do we calculate? Instantaneous power and then average power. Okay? Have you noted down? So write down point number 13. Instantaneous power. Small p will be given by V into I. That will be Vm sine omega t, Im sine omega t plus pi by 2. So sine omega t plus pi by 2 can be written as cos omega t. So Vm Im sine omega t cos omega t. What is sine omega t cos omega t written as? Half sine 2 omega t. So that is the formula. Expression for instantaneous power. What will be average power? Average power given by capital P will be finding the integral over this period 1 upon 2 pi, integral going from 0 to 2 pi, P d omega t, that will be 1 upon 2 pi, 0 to 2 pi, Vm Im by 2 sine 2 omega t d omega t. Now again, if you solve this further, your average power will be 0. You can work it out. So that means power absorbed in a pure capacitor is power absorbed in a pure capacitor or pure capacitance is 0. Okay? And now we solve one numerical on AC circuit with a pure capacitor. See, pure capacitor, in a practical capacitor, there is small resistance. So average power won't be 0. But if it is a pure capacitor, then it is 0. There doesn't exist a pure inductor and capacitor for your record. Always there is small resistance. Okay? Can we start? Write down the numerical statement. A 318 microfarad capacitor is connected across a 230 volt 50 hertz AC system. Determine A, capacitive reactance, B, RMS value of current, C, equations of voltage and current. A 318 microfarad capacitor is connected across 230 volt 50 hertz AC system. Determine capacitive reactance, RMS value of current, equations of voltage and current. So let's start solving and write down the given data. So given is capacitor value 318 microfarad, V RMS or V is 230 volt, frequency is 50 hertz. Okay, so let's start solving now. So what's the first thing we need to find out? XC, capacitive reactance XC is given by 1 upon 2 pi FC. So please substitute the values 1 upon 2 pi into 50 into 318 into 10 raised to minus 6. Here students make a mistake. They don't put 10 raised to minus 6 and the answer is wrong. So micro means 10 raised to minus 6. So please carefully tell me this number. All of you calculate in the calculator. It will be 10 ohms. Please check. Students land up in trouble over here. It's fine if you don't use your calculator, you directly make a mistake in exam and you lose marks. That's it. So practice now. Next, got this value 10 ohms. Next is we calculate voltage. Now tell me what will be the voltage? Voltage formula. Current into impedance. And what is impedance in case of inductance? XC. So I into XC. And how will you find I? Now next. Yes. So find out that we need to find I. So it is V upon XC. V is 230 divided by 10. So current is 23 amperes. That is RMS value. Now we need to find the expressions of I and V. So we need to find Vm and Im. So Im is root 2 times IRMS. IRMS is 23. So root 2 into 23, that will be 32.58 amperes. Please check this number. Similarly, Vm will be root 2 times VRMS. That will be root 2 times 230. That will be 325. This is 325 point, how much it is? 27 or 26, right? And also we need to calculate omega 2 pi f, 2 pi into 50, that will be 314 radians per second. Next we write down the expressions of V and I. So V will be Vm sin omega t, that will be 325.27 sine of 314t. Similarly, I will be Im sine of omega t plus or minus. It will be plus or minus over here. Omega t plus pi by 2. So it will be 32.53 sine of 314 plus pi by 2. So these are my expressions of AC voltage and current. And with this, we complete the AC circuits with pure R, pure inductor and pure capacitor. And hence we complete 2.2. Now, we'll introduce the next part and then I'll stop the lecture. 10 minutes more, that's it. Okay. Completed? Now, write down the difference between AC and DC circuits. Write down DC circuits and AC circuit. In a DC circuit, do we have R or L? Have you seen R or L in any theorems or any this thing? No. Only R can be considered. Okay. Whereas in AC circuits, R, L, C are considered. Correct? For AC circuits, you're dealing with RLC. Here write down opposition to current flow is resistance R. Right? Here opposition to AC current flow is impedance Z. Okay. Also, further we can write down elements L and C of a opposition, that is L offers opposition XL, inductive reactance, and C offers capacitive reactance, opposition to the current flow, to the AC current flow. And what is XL given by? Omega L. And what is XC given by? 1 upon omega C. You should remember this throughout. Now, in a DC circuit, Is the magnitude of the voltage affected by frequency? Frequency को affect नहीं होता, but in a AC current is it affected? Yes. So write down third point, magnitude of current in AC circuit is affected by supply frequency. Okay. Okay. In a DC circuit, if I want to add or subtract voltages, can I do that arithmetically? I can add and subtract voltages arithmetically. Can I do the same thing in AC? AC, I cannot add the voltages arithmetically, but I will use phasor diagrams, right? So write down, in DC circuits, voltages or currents can be added or subtracted arithmetically. Okay, over here in AC circuits, what happens? They are added or subtracted by a phasor. So here actually there is a phase difference of 90° between AC voltage and current through L or C, because resistance में there is no phase difference, right? So therefore the voltages or currents are added graphically or by phasor. So therefore we can write current or voltages are added by phasor representation. You know now, rectangular to polar, that's why we add it. We can add voltages, we can add or subtract by rectangular form, and we can divide and multiply by when it is in the polar form. We have done that, right? So next we'll start with, introduce with, write down over here. I'm not starting it, I'm just informing you what we will going to recap of the next lecture. So write down over here, series AC circuit. Series AC circuit. In this, under series AC circuit, we'll study RC series, RL series, RC series and RLC series. Similarly, in parallel also we have RC, RL and RLC parallel. Okay, now whenever we analyze these three circuits, here the point of interest, the main aim is, or the point of interest in the above series RC circuit is finding the things below. So what do we find? The point of interest is finding first the phase angle. So remember, this is very crucial. For all of them, it's a common procedure. We find these things only for every circuit. So find out phase difference or phase angle between AC voltage and current. Second point of interest will be, anyone? Nature of the circuit. Now you will say RC hai, RL hai. How do I know nature of the circuit? RLC. So next thing is point of interest in finding nature of the circuit. Whether resistive, capacitive or inductive. After doing that, the next point of interest will be finding circuit impedance, correct? Circuit impedance Z. And the last point of interest will be finding power consumed, average power consumed. So these are the things we need to find for a series RC circuit. This we should keep in mind. And that's it for this lecture.